Diffraction grating. That's what we are going to analyze in this video. Our objectives are: what is a diffraction grating? Calculate the slit spacing for a diffraction grating. Analyze the pattern formed when light passes through a diffraction grating. Diffraction grating. It is a device that is made up of many small slits. Here in the diagram, we can see a diffraction grating which has 600 lines per millimeter. Diffraction grating is usually made of a thin glass on which multiple fine lines are scratched with the help of a diamond point. And these fine lines would act like slits. When white light passes through diffraction grating, we can see a center white fringe or band is formed, and it is flanked by colored fringes on either side, and they appear to be brighter as we can see in the picture. Diffraction grating gives the same pattern as the double slit interference pattern, but the difference is here the bands are narrower and brighter. Let's see how to calculate the slit spacing. In the diagram, we see a diffraction grating which has 600 lines per millimeter. And we want to find out what is the spacing between two slits in this diffraction grating. So the formula for calculating the slit spacing is d equal to 1 over n, where d is the spacing between two slits and n is the number of lines per unit length. We have got 600 lines per millimeter, which is n. So n is equal to 600 lines per millimeter. But we need to convert millimeter to meter. And therefore, we are going to write millimeter as 10 to the power of negative 3. The reason is 1 millimeter is equal to 10 to the power of negative 3 meter. We can now calculate the value of n, which will come out as 600,000 lines per meter. Now we'll substitute it back into the formula for d and use our calculator to get the answer for d. We can see that the value of d is 1.67 into 10 to the power of negative 6 meter. And that's our slit spacing for the given diffraction grating. Let's investigate a diffraction grating in little more detail. The figure here shows the side view of a diffraction grating. The slit separation is d and the path difference between the adjacent slits is d sine theta, as we can see in this small triangle. The pattern which forms on the screen is a result of diffraction as well as interference. The light, as it enters through the slit, it diffracts, and these diffracted rays in turn interfere and produce the pattern which we see on the screen. The pattern which is formed on the screen is a combination of constructive and destructive interference. Therefore, we can see that we have labeled first order maxima, central maxima, first order maxima, and then in between we will have the minimas or the destructive interference. The condition for maxima is d sine theta equal to m lambda, where m can be 0 or plus minus 1 or plus minus 2. So this m is actually giving us the order number of the diffraction pattern. If m is equal to 1, we are going to call it as first order maxima. If m is equal to 0, it is called as 0th order or the central maxima. And as usual, in between, we expect the minimas or the destructive interference to be formed. Now we can see that the fringe spacing, that is this fringe spacing, if you take two consecutive bright fringes and we want to figure out the fringe spacing, it is defined by sine theta. So if you want to increase the fringe spacing, we need to increase the wavelength. We can rewrite this equation as sine theta is equal to m lambda over d. And hence we can see all the factors which will affect sine theta. If we want to increase sine theta, that means we have to either increase the wavelength or decrease d, which is the slit spacing in the diffraction grating. Let's compare the intensity in two-slit interference and diffraction grating. So the pattern which is formed on the screen, if we investigate and compare, we see that in diffraction grating, the bright fringes are sharper and the dark fringes are broader. Whereas in two-slit interference, the bright fringes are little broader and the dark fringes are very narrow. Let's check the difference between the diffraction pattern formed by a monochromatic light and a white light. Mono means single, chroma means color. So monochromatic is single color. So the first picture shows us the diffraction pattern of a green light, whereas the second picture shows us the diffraction pattern of the white light. So the difference which we observe is that in green light, we get a pattern of bright, dark fringes. Whereas in the white light, we see there is a center white fringe which is surrounded by colored fringes on either side. These colored fringes are separated by dark fringes which we can see in the diagram.